Okay, let's get going. Hello, everybody, and thank you for joining us in this latest Diffblue webinar, where we're going to be exploring briefly the next generation of AI for code, by which we mean the new features we've recently introduced into our AI-powered code writing product, Diffblue Cover, that help teams to deliver Java software with more speed, confidence, and insight. My name is Pete Yavsley. I'm the head of marketing here at Diffblue, and I'll be running the session today. But more importantly, I'm delighted to say that I'm joined by my colleague, Matt Richards, who's our head of product here at Diffblue. Matt, thanks for joining us.
Nice to be joining you. Thanks for having
me. Excuse me. So as usual, just a little bit of admin before we begin. This call is being recorded. We will send a link to the recording out to everyone who registered. So if you want to recap anything or want to share a copy of that with colleagues, do look out for that link by email. As ever, everyone's on mute on the call today, except for the presenters, but do please feel free to add your questions into the Q&A panel during the session. We'll get to those at the end. We're definitely happy to cover any of those off as best we can today. So without further ado, let's move on, and we'll take a very brief high-level look at today's agenda. Very simple. We will be taking a quick look at what Diffblue Cover is and what it can do, just for the benefit of anyone who may be less familiar with the product itself, and then we'll dive into what those new features are and how they can help Java teams with unit testing and more broadly. So just to set the scene, I'm sure many, if not all of you on the call with us today, are very familiar with the importance of unit testing and why it matters and what we're trying to do. But this is a quote from one of the organizations we were speaking to recently, a major financial services provider, and their Java development lead said they're shipping fast, but they want to make it faster. And one of the things that was holding them back was how well they could execute their unit testing. They knew they needed it for quality. They had good coverage, actually, but it was taking too much effort. They wanted to move faster. And of course, that's what we're really all about these days with unit testing, is trying to enable faster delivery of high quality software. And particularly when we talk about some of the bigger, older code bases we'll touch on as we go through the session today, that's really critical. But, and there's always a but, of course, and any developers with us will be much more familiar than me with the challenge of unit testing and how much time and effort they have to spend on it. And we typically find with the clients we work with and the companies we talk to that anywhere between 20% and 50% of a developer's time might be spent writing, maintaining, working on unit tests, which is a huge resource drain, of course. And on top of that, it requires potentially really deep understanding of the code you're working on. It's not a trivial task. It's not something just anyone can do. And Matt's going to talk a little bit about that, I think, later. And what that means is that when we're trying to be agile, when we're trying to move fast, when we're in the spotlight and we're trying to deliver new features or fixes or new functionality and respond to the market, it can be difficult sometimes to focus on this regression prevention, this idea of writing unit tests if they're not already there, and try to really dedicate the effort that it deserves, even though it might be a day, two, more a week already. So there's a challenge here. We know they're so important. They do help us to move fast, but they take a lot of effort. And that's where Diffblue Cover comes in. So at a very high level, Diffblue Cover is an autonomous tool for writing Java unit tests, so no developer intervention required. And it does that by using a form of AI called reinforcement learning. So Cover Core, the central part of Cover, will write and maintain entire Java unit test suites for you without any human intervention. So quite unlike some of the other AI-powered development tools that are coming into the marketplace today, where you need the developer to do that checking. So Cover runs locally within your environment, on your desktop or in your CI pipeline. It's completely deterministic. It will produce the same results each time, obviously very important for unit testing, unlike some other tools. And because it's not connecting outside to other cloud servers, it's a secure way to write this kind of code automatically. So that's the very quick high-level intro. This is what we're going to look at today in a bit more detail. 4 new features that help you to deliver Java code with more speed and confidence and insight. Reports, refactor, replay, and optimize are the 4 things we're going to look at. Just before we do that, let's take a close look just for a couple of minutes at that core code writing capability of Diffblue cover, just to set the scene for those new features and the context that they fit into. So Matt, this is where I really want to bring you into the conversation, because you're the expert here. What we've got on the screen here is an example of what cover can produce, and I know you like to start here. So why don't you talk us through what this is, and how it's representative of what cover can do?
Sure, definitely. Well, this is really my favorite unit test, and yes, I do have a favorite unit test. It's a great example of what Diffblue can do, because it's a really complex unit test. It's not particularly long, but it's an example of a unit test that requires really deep understanding of how to write a great unit test. And typically, if you were to write this unit test by hand, and you've not written a unit test like this before, this could take you sort of half an hour or 40 minutes of Googling, of reading documentation, Stack Overflow, trial and error, just trying to understand, how do I test this functionality, and how do I know that this unit test is a good unit test? So really the key thing that Diffblue is doing here is it's writing unit tests like this completely autonomously, in this case a couple of seconds. And that's really the only way that you can tell that this unit test was written by a machine, is that it was only written, it only took a couple of seconds to actually write. So this is why I use this example. It's really complex. It's really hard for humans to do. Just to take you on a tour of this unit test, this is a real, what I call a true unit test. That's where we're writing one unit test per behavior within a method. So if we have a method that has, say, 3 different pathways through it, really exhibiting 3 completely separate behaviors, we want to write one test for each of those 3 pathways. So this test is testing one particular pathway, one particular behavior of the method. And in this case, we're testing the upload of a file to an Amazon S3 bucket. So it's a true per behavior unit test, completely human-like. This is, any developer would be proud to write a unit test like this. Because the unit tests that Diffblue write are very consistent, they're always per behavior, per unit test, and follow the arrange, act, assert formula. It means that you're able to use our unit tests to consistently understand what the code does. And this is what we mean by the third point here. The Diffblue unit tests that we write document your code. By reading those per behavior unit tests before you make a code change, you understand, what does this piece of code do that I'm about to change? So actually the Diffblue unit tests actually make the chances of you introducing a problem into the code lower, because you understand the code better before you make a code change. Our customers tell us that the biggest problem for them to solve is stopping new problems being introduced to existing code. And because the Diffblue unit tests consistently document your code, you're actually more likely to write good code in the first place. And then the main reason I love this more than, or sorry, the summary reason why I love this unit test is it catches regressions. And you'd be amazed by how many people, and we must have all seen this, unit tests that have been written by that don't actually catch a regression, unit tests that never actually fail. And this is a real regression busting unit test. So it's really the whole package, but ultimately catching regressions is what we're trying to do.
Great, thank you, Matt. So good introduction into cover there. Just give us, we're not going to get into the details here of how the AI works and the technical side of it, but just give us a very quick overview of how cover is writing tests like that.
Sure. So what we're trying to do is write unit tests that describe the current behavior of your code, so that when you then make a code change, you can use those unit tests after your code change to catch regressions, catch behavioral change. So the way we do that is, first of all, we analyze the code, and we do that by taking the bytecode for each method of your application one by one and putting that bytecode into a harness in our AI engine. So we put your code into our engine, where we can run your code thousands of times, searching for different ways to call that code that are going to trigger all of the various pathways through that code. Our AI is looking for those ways to call the method to trigger the code, and then writing a set of assertions for each pathway that describe the behavior of that code. So that those assertions are describing the side effects of that particular method call that it found. So again, if you have a method with 3 pathways, our AI will look for 3 different method calls triggering each pathway. And then it will create 3 assertions that describe the side effect of each of those method calls. And what we end up with is 3 tests. 3 method calls, 3 assertions equals the 3 tests. So they're ready to go. They're 100% ready for production use for that one method. We do that for all of the methods in your application, and we end up with a suite of unit tests that you can commit to your code base. And as I say, they describe the current behavior of your code. So now you can make a code change and then run those unit tests, and they will tell you how the behavior of your application has changed, either helping you validate that it changed in the right way, so the changes you made intentionally have actually manifested, but also helping you to spot undesirable changes, regressions, behavioral drift that you can rectify before that code makes it into your code base.
Great, thank you, Matt. Okay, so a bit of detail there on how Cover works. Just very briefly, you've mentioned committing to a code base there. How can people use Cover if they want to automatically write the Java unit test?
Sure, so there's 3 flavors of the interaction. The first 2 are allowing a developer to automatically write unit tests on their desktop as they develop. So we have a plugin for IntelliJ where you as a developer write some code, make some changes to a method, click one icon, and we will just automatically write the unit test for that method. And to help people who are using CLI, we have a CLI tool that does exactly the same. You ask Diffblue to create a test for a particular method, class, package, and we write those tests. So that's helping the developer as they're actively coding. And then we have our CI integration, which means that when your developer is ready to commit the code, they push that into CI, and the CI pipeline is ensuring that Diffblue has analyzed all of the code, that it has created and updated as much of that coverage as possible. And that's really important, that we don't just write those unit tests, but we keep them up to date. That's a significant part of the cost of unit testing. And also we then provide back to our reporting tool all of that information that we found whilst we were running your code thousands of times. All those insights about what did we find in your code base, what is important for you as a developer to go back and look at.
All right, thanks, Matt. Well, let's get into that. You've talked about the reporting tool. Let's look at that now. So let's get into the question of what's new in the product and what these new features can do and how they can help. So again, just to recap, we're going to look at Cover Reports, Cover Refactor, Cover Replay, and Cover Optimize. We'll look at each of them quite briefly. Again, if you have any questions, do please put those in. And of course, there's a bit more information on the website as well. So let's start with Cover Reports. Something slightly different from the unit test writing and maintenance and test coverage question. Matt, tell us what Cover Reports is all about and how it helps Java teams, what it's for.
Sure. So we're all used to tools like SonarQube, tools that tell us how much coverage we have and whether we've hit a particular coverage bar. And these are called static analysis tools. There is a serious problem with purely looking at the quantity of coverage, because how do you know that that coverage is the right coverage? How do you know you're mitigating the right amount of risk in the right places? How do you know why you can't get more coverage? How do you know what you should be spending your time on? Because Cover Core is running your code thousands and thousands of times, we learn a huge amount about your code. We know what the code is doing. We know what it's trying to access. We know how it's trying to access it. All that knowledge that we create whilst we're writing those unit tests is very valuable to aggregate and to tell the user, be it the actual engineer, an engineering manager, a department head, the head of engineering, what that means, what that means at all those different levels, and how that data can help you de-risk problems further down the line. So we're helping you visualize the state of your unit testing, but also giving you real actionable insights about where there is risk and what you can do about it.
Okay, great. Well, let's take a look at that then. This is an example of kind of one of the main dashboards. There are various different ones in reports, I know, but one of the main dashboards that summarizes that kind of information. Can you just talk us through what people can see and how they can use this and what it tells them? And then we'll look at a couple of other things as we go.
Yeah, so first of all, this project here, we can see we have 77% unit test coverage. That's typically all the information we get from static analysis tools looking at unit testing. But what Cover Reports is, first of all, doing is it's splitting up that 77% and telling you how much of that did my developers write and how much of that did Diffblue write, and what coverage are both developers and Diffblue overlapping. So there may be a whole series of your code that both developers and Diffblue are able to cover. Why not let Diffblue cover that for you? So we can see here straight away 26%, which is this light blue color. 26% of your total project is covered by Diffblue, and your developers are also writing tests for it. So here is an opportunity to let Diffblue do that work, offload that vital but tedious task to us. The yellow area is a really interesting area, and no one else can do this. The yellow area is telling us where the code itself is untestable. And what we mean by that is when we've written the code in the first place, maybe it's a legacy piece of code written 10, 15 years ago, or even written yesterday, but if it wasn't written with unit testing in mind, it may not be testable. So that means we as Diffblue, but also you as a developer, cannot write unit tests for that code without changing that code. So we're able to show you, hey, this piece of code is not testable. That's the ceiling to your test coverage. You need to go and refactor that code to make it testable, or let Diffblue do that refactoring for you. And we'll talk more about that later with Cover Refactor. But that yellow part is really interesting. We've seen projects where 50% of the project is just impossible to write unit tests for without refactoring. And the team is battling to try and get that unit test coverage up, but they just keep hitting that ceiling because the effort required to understand how to make it testable is just an insurmountable mountain. And then we have the red area. This is where technically the code is testable, but neither Diffblue nor your developers have been able to cover it. And maybe this red area is an area that is harboring risk. Maybe there's some code that's so complex, so convoluted, that a developer should go and look at. Maybe spend some of that light blue time on unit testing that red area. So it's about breaking down, giving you the knowledge of what is actually happening under the cover of that unit testing. And then, as you mentioned, there's other dashboards where we can look into different types of risk and pinpoint some examples of real big problems that you should go and look at.
Oh, sorry. Excuse me. We'll look at a couple of those other dashboards in a moment. Let's just click into that question about why that red section matters and why it's good to get beyond that big coverage number. Explain to us the sort of scenario we're trying to illustrate here and how it could turn out.
Definitely. So I've already told you that I have a favorite unit test. I have a favorite unit testing story as well. So here we have a project. It's a module of a project. 90% coverage Cover Reports is telling us we have here. So we feel really confident about that. As an engineering manager, 90% is great. As Diffie says here, there's absolutely nothing to worry about. We should all be comfortable. But what about this red bit in the bottom right-hand corner? That looks to be quite big, and everything else is green. Why have I got this one big red bit? What is that? So click that level deeper, and we ask ourselves, what is this piece of code? So we dig into the code base and we actually find out that originally this piece of code was written back right when the project was first started, back in 2010. So it's an original piece of code. It hasn't been modified though for over 10 years. And it's actually, yeah, it's a big piece of code. It's 5% of the total code of this module. And then when we scratch the surface of what is this code doing, we find out it's really complex. The cyclomatic complexity here is indicating that this is some really potentially gnarly code. And now we're getting worried. it's big, it's old, it's complex. What's going on here? Why is this not being covered? So we then go and ask, well, what is it? What does this piece of code do? And it's the database restore method. So this is the piece of code in your project, and this is based on a real world story. This is the piece of code that when this application fails and we need to reload the application, we need to restore the database from a backup, this is the piece of code that does that operation. It's quite a generic piece of code, hence probably why it's not been updated in a long time. And it probably worked fine when it was first written, but maybe this piece of code isn't exercised very often. Very few people have to restore after a failure, so maybe it's not got the love and attention it needs. But I'm sure you can imagine that in a failure situation, one of your customers' system goes down and they think, hey, well, that's okay. There is a backup restore method for my database here. Let's load the backup file, and it fails. So we feel confident we have that 90% figure, but it's the wrong 90%. In fact, with this project, we covered the 90% simplest code, but the actual most complex piece of code, the single highest piece of risk is still there. And that confidence that 90% gives us is completely misplaced. So let's pinpoint that and let's say, hey, go do something about this. Go add unit tests. Go refactor this method. Go and action this in one of a number of different ways.
Okay, cool. Thank you. So let's very briefly then click into a couple of the different views that we can see in reports. You know, I hope our audience can understand how that understanding an extra level of insight can help them, but we can go to different levels. So we can, I know we can go from very macro to a much more detailed view. So just give us a very quick introduction into how that's helpful, who can use it, what it looks like.
Sure. So let's imagine all the way from a head of engineering who's got 2,000 software developers, hundreds and hundreds of projects. They still want to be able to understand where is the risk contextualized at my level, and then want to be able to drill down into that risk through their organization, through the individual departments, down into individual teams, down to individual applications, and then for the team leaders, the managers, the actual engineers and architects, being able to click all the way down to the methods and see the code and see this is where risk lies in your project. Just as we saw with the database restore method, how do we highlight that sort of risk in an appropriate way at the appropriate level of the organization? That's what Cover Reports does. I know as an ex-engineering manager in a huge multinational company, I understand what's going on at the ground floor level, but sometimes I don't have the aggregation of that data at a level I can see. So we're providing visibility of this data at all levels of the organization in an appropriate way for that audience.
Okay, and that's probably data that we wouldn't maybe otherwise be able to see, especially across those projects in a comparative way. So
no, it's an Excel job, and I know personally I've had to do this in Excel. I've had to go and find that data and bring it in and try and visualize it. And this is what people tell us all the time, is that they're forced to try and aggregate this data themselves.
And speaking of which, speaking of data aggregation over time, just the final thing we're going to touch on here out of the various things we can see in Cover Reports is this idea of being able to track status and progress over time. And perhaps particularly important, I guess, when it comes to this question of maintenance and confidence. I think we all know how easy it is to slip back in terms of testing effort as other priorities arise and teams change. So I guess, how does this kind of function work in terms of reports, to wrap this up?
We've all got a perception of how we believe unit testing should be done, and we'd all like to think it's sustainable over time. And we see a lot of organizations that have low coverage. They put in this big effort to get that coverage up, and again, they feel happy about it. But over time, that coverage slips. And it's not necessarily the quantity of coverage that slips. Maybe they hit that 70% coverage target every time. It's always just enough so that they're allowed to move forward with the pipeline. But is the quality of that coverage being maintained? Is that coverage going to catch regressions? Am I still testing the most important stuff in the most important way? Am I letting the most complex parts of the code slip through? And what we're doing with the data is we're showing you the this data over time, such that you can see not just am I hitting my targets over time, but is the actual quality of that unit testing persisting over time? And is there new risk being introduced over time? And again, this is something that cannot be done today. And we're using all that data that we gather for every single PR, every time the pipeline runs, we're using that data, aggregating it, and showing it you in a way that is super actionable.
All right, great. Thanks, Matt. So lots of power there in terms of helping us to unit test more effectively, as well as having that automation in the back end to write and maintain them more easily. Let's talk about cover refactor. You mentioned this already obliquely when we talked about reports. What is this refactor feature, and how does this one help? What is it doing?
Sure. So we mentioned briefly already where we have a project that is not unit testable. For whatever reason, we weren't thinking about unit testing when we wrote the project, or we were thinking, but we didn't quite make it testable enough. So this stops us writing unit tests. What Cover Refactor does conceptually is quite simple, is it automatically refactors your code, changes your code to make it testable. And what this allows us to do is when Diffblue cover runs, is we can access more of the code, we can test more of it, and those, particularly in the legacy projects, we can access all of that gnarly code that was would have taken a human a long time to make testable, or at scale is in a lot of situations impossible for humans to actually make testable because it's just so complex, the interrelationships between all the code.
And I guess the other aspect there, Matt, is just simply identifying, getting back to reports, that what's testable and what's not when you've got millions of lines of code.
Yeah.
So I know that the first version of Refactor, which this is, looks at one specific use case, and there's a lot of potential for what it could do in future. So can you just talk us through what Refactor solves for today?
Sure. So again, conceptually mega simple, really hard for humans to do. So here we've got a class and a method called increment. The ability to test this is inhibited by the fact that the field counter is private. So a unit test without using reflection, which is bad practice for many reasons, but without using reflection, we can't access that field counter. So this unit test on the right-hand side, we can do everything but assert the actual correct value. So this unit test on the right would pass and it would actually count towards coverage, but it's not actually testing anything. The reason this is so difficult for humans to solve is it's not actually fixing this situation to make this testable. It's identifying that this piece of code needs to be fixed in the first place. Imagine you've got 2 million lines of code and all the dependencies between that code. Just imagine that the dependency tree of complex enterprise applications, knowing that you're trying to test method A down here, but method X, Y, and Z that are way up the dependency tree may not be testable. That has a knock-on effect down the dependency tree. So actually making this testable is the easy bit for a human. The most challenging part is finding where it actually needs to be done in the first place.
But it could still be a lot of effort, as you said, in millions of lines of code. So what does cover do?
So here, what cover has first of all done is it's understood that the field is not accessible. Back up in methods X, Y, and Z. It's said we need to be able to access this field counter, and Cover Refactor has added a getter, a public getter that allows the subsequent dependent methods to access that, the unit test to access that field. So what we can do now is we have the same test now, but we have an assertion. So we are able to write a test that can pass or fail. As you can imagine, at scale, we can run this on projects and find thousands and thousands of examples where this lack of accessibility is stopping us from writing unit tests. And we can see that test coverage bump by quite a significant percentage, but also the quality of those tests that we already written increases as there's more fields to actually assert where the side effects are changing.
All right, great, thank you. So that's our second new feature, automatically improving the testability of your code to get the test coverage up. Quite a powerful concept there. Let's talk about cover replay, the third one in our 4. a slightly different concept here, slightly more technical. Give us the Cliff Notes, the brief introduction overview here, and then we'll look at an example.
In large applications where you've got many developers working on their part of the code, they may not understand the flow of data end to end through the application. And this makes it particularly challenging to write unit tests when we don't have that full picture of the context of how does data enter my part of the application, in what order does it enter, what are all the dependent objects that need to be created to allow this data to flow through the application. So what Cover Replay is it's a Java agent that attaches to the JVM underneath your application as it runs in the end-to-end test environment. It's over here on the right-hand side, observing your application running and recording the different types of data that are flowing through the application and the order in which that data is those objects are created and the order in which they're executed, such that we can then in future feed that data into Diffblue Cover Core to actually write unit tests using real world like data, so data that it's observed in the running of the end-to-end tests, and to do that in the order that it happens in a real world application. So seeing that object B is created before object A. So what we end up with is more coverage because we're able to access more of the code with the correct data. The tests are more useful because they exercise the code in a more real world way than that microscopic level that unit tests traditionally look at. And the tests are more readable because they're using that real world like data. So therefore it's more recognizable what the context of the application is doing as it's processing that data. The final thing I'll say here is we run on the end-to-end tests on the right-hand side of your pipeline rather than production. This is a tool that monitors that real world like data without actually needing to see production data. So it's still secure, it's still safe, and it's still ensuring that the privacy of your production users is maintained.
So we're going to get that feedback to developers faster by using more unit tests, hopefully, than end-to-end tests, or at least we might find our end-to-end tests run faster with less triage and problems because we've increased our unit test coverage. So great, that all makes sense. Let's take a look at that example that I mentioned. So this is a test written without replay, correct?
Sure. So this unit test is testing a particular database operation. This is one of many tests for a particular method. So this is one behavior for a particular method. There's nothing wrong with this unit test. This is a valid unit test, but the problem is we don't actually know how to write many other unit tests for this method for many of the positive pathways. So this is a negative test. The positive tests are really difficult to write because we don't know what that real world data looks like. And this is something a developer might come across is, I don't know how to actually, I don't know what the data looks like exactly, and I'm not sure what order I need to build these objects in. So valid unit tests, but this is the problem here is that we are lacking those positive test cases. So there are more tests that we can write. What we can see on as we move forward is an example of another test that we can write once we have Cover Replay running. So this is a positive test case that we were only able to create because we can actually observe the application running. We can see how this method is called. We can see the chain of objects that had to be created to call this method. And we were able to write what is a really great regression busting unit test. Be challenging for humans to have that end-to-end context of the application to instinctively know how to do this. It would take a long time to do.
Great, thank you. So yeah, shifting more left, more unit tests. But of course, as everything has sometimes a cloud inside the silver lining. More unit tests means your unit test suite is going to take longer to run. So we're trying to give feedback to the developers faster, but actually we're saying, hey, you've got to execute a bunch more tests before you can do that. And I know that's where Cover Optimize comes in, which is a very simple but powerful idea. How does Cover Optimize help in this execution scenario rather than the test writing side?
So running thousands and thousands of unit tests does take time. It also depends on the unit tests themselves. So the Diffblue written unit tests are optimized to run quickly, but often we find with a lot of human written unit tests, they can take a long time to run because they're testing chains of behavior and maybe calling outside services, etc. So what Cover Optimize does is it decides for your code change, what test do I actually have to run? Maybe there's thousands of tests that every time a developer makes a change they're running, when in reality, the vast majority of those tests are not going to actually catch a regression. They can't catch a regression because the tests are nothing to do with your code change. So Cover Optimize selects only the unit tests necessary to actually exercise your code change. And this is both human and Diffblue tests. So this works with all JUnit tests. So as you can see here, you have your code base. The developer makes a code change. And that might be a very simple code change in a very limited part of the application. They call their test command like mvn test. And the Diffblue Cover Optimize Maven plugin in that case intercepts that request for running the tests. We use the information that the Cover Core AI has created to understand which tests should be run. We select those tests, and again, those are the Diffblue and developer written unit tests. We select only the tests that can exercise that change, and then we pass that on to your build system to actually run. So we're limiting, in some case, dropping that amount of time to run the unit test significantly.
Well, let's just take a look at an example of that. Thanks, Matt. But this is some data from use of Cover Optimize within Diffblue, I believe, and we've seen a really big reduction in CI time in terms of this test execution.
Definitely. I'm sure you can imagine we have really great unit test coverage here at Diffblue, and we have some really complex code, which is why there's so many unit tests. So in our pipeline, it takes over an hour to run all the unit tests. But with Cover Optimize, we are, as you can see there, we've seen overall a 59% reduction in CI time. That means we're obviously saving time, and from a cost perspective, that's great. And we're spending less time running cloud compute to run those tests. But also the developers can stay more focused. They're not context switching. They're able to get that response much quicker and still stay in the context of that code change. So it's had a really great impact for the better wherever it's used.
Great, thanks, Matt. Well, that's a brief introduction to those 4 powerful new features that we brought into Diffblue Cover. And just to try and pull that together and frame that, an example of a very common use case, a very common reason to adopt Diffblue Cover in the first place is some kind of application modernization project. It could be re-architecting existing code for the cloud. It could be breaking a monolith down into microservices. Any number of different reasons. Could simply be adopting more agile working practices and trying to deliver code more quickly in faster sprints. And the things we've talked about today all dovetail together and build on each other to help Java development teams do that more effectively and deliver high quality code more quickly. So as we've said, for example, in an application modernization project that might take months or years to execute, you might have a lot of different iterations as you go through that process and you're writing your new code or updating your code. Cover Core is going to write a huge amount of tests for you, save you a massive amount of time, give you the baseline in the first place, keep that updated and maintained as you go. Reports is then going to identify where there might be areas you want to give a bit more attention, a bit more focus, prioritize the development resources you do have. Refactor will help you to get more coverage by improving some of that existing code and making it more testable. Replay is going to be, in certain circumstances, helpful, maybe as you get a bit later in the project, to iterate through some of those end-to-end cases with more complex data, shift that left and get more unit test coverage. And of course, every time you do this, every time you go through this loop, you're going to be able to use Optimize to cut that CI time, that test execution time in half, so that you can move more quickly and get your code delivered faster and get your project ultimately delivered faster as well. So all built from that core Diffblue Cover technology, and connecting to each other to help you generate more unit tests more efficiently and move faster. And just in summary, that's what we can see here with Diffblue Java, with Diffblue Cover even, you can spend less time writing and maintaining unit tests, really significant. You can document that code automatically, which helps with future code changes, and you can deliver high quality code faster, which means in particular, very often you can change those existing legacy applications with much more confidence and much more speed. And also important in a lot of organizations for development teams, you can just hit those code coverage targets you have to meet with much less effort. So you can focus on other work, more important, more interesting, more value add work than unit testing might be to your development teams. So quick summary there. So just to wrap things up for today's session, we just touched very briefly on the idea that effective unit testing is a really powerful enabler of faster software delivery, but we know that it's a challenge for developers day to day, let alone when you're doing some kind of big project like an application modernization. And AI is something that can help you solve this problem. And in the case of Diffblue Cover, it can automatically write and maintain those Java unit tests for you at scale. And now it offers these new ways, additional ways on top of that core cover functionality to help you accelerate that unit testing process, increase your coverage, and deliver your software change faster. So thank you to everybody in the audience for joining us today. We said at the start we would take a look at some Q&A before we wrap up. So let's do that before we end the session. We've got a few questions I think I can see that have come in. Yeah, a couple of questions here, Matt. I mean, I'll paraphrase. We went through reports in quite a bit of detail, but we've got a couple of questions about SonarQube, very commonly used, obviously, and has different applications and functionality, but particularly with the unit testing, can you just recap what reports tells you that SonarQube doesn't? Like, how is it different in terms of what it can do?
SonarQube is doing static analysis, as I mentioned. So it's following a set of rules. It's comparing what it sees in the code of your application with its opinion of certain rules and tells you whether you've broken those rules or not. And it helps you to track your coverage against a particular target, and you either pass or fail. What Cover Reports is doing is it's giving you that much deeper insight into what your code is actually doing. Because we're not statically analyzing the code, we're actually running it. We're able to give you the very actionable insight of this is actually a problem. This is actually something that could really bite you in the future, and you should do something about it in the context of the rest of the application. And that may not be the case in another application. A similar situation in a different context may be different. So it's think of it as the difference between SonarQube ticking off against a set of rules versus Cover Reports, where it's like sitting down with an expert who is looking at your code and saying, hey, we should have a look at what's going on in here.
Okay, great, thank you. And there's a related question here, which I think is interesting. You talked about Cover being in the IDE or being in the CLI. Obviously, reports with the dashboards there is slightly separate, and one of the audience has asked us how and where reports is hosted, or is it part of the Cover application?
So great question. So Cover Reports is hosted in your environment. So you can host it in your own cloud resource. You can host it on-prem on a server. It is a server-based application that you can run anywhere. And the data is uploaded from the actual running of Diffblue Cover to Cover Reports over your own internal network. So it's all internal to your environment. There's no external remote cloud component to this.
Cool, thanks. We've got a question here that isn't actually about the new features, but I do think we should just cover very quickly because it's a really important one. A questioner asked what data is Cover's AI trained on? And of course, Cover's working a slightly different way. Can you just very briefly recap the difference in this area between Cover and other tools?
Sure. So you mentioned the word training there. We all hear about trained AI all the time, where and just to recap, that's the idea that you show your AI a lot of different situations. So you teach it how to recognize certain patterns. And then in the future, that means it can recognize that same pattern in a new piece of data that it's not seen before. typically that's what we think of when we think of AI. Diffblue doesn't train the AI in that way. We don't show it unit tests for it to learn from. And the very good reason for that is multiple reasons. It's slow, it's non-deterministic, so you get different results every time you try. And as well as being slow and non-deterministic, it doesn't give you accurate results because the data that you've trained on isn't necessarily correct. So if we train ourselves against a load of Java unit tests, how do we know that those unit tests are correct in the first place? So we don't do that. We use what's called reinforcement learning, which is where we actually teach our AI the rules of Java, a bit like how you could teach an AI the rules of chess. And by giving it the rules and teaching it what success looks like, teaching it what a good unit test looks like, what are the features and what does a good unit test do and how does it behave, and then the AI is writing a unit test to achieve a great looking, great performing unit test, but following the rules of Java. So it's a bit like teaching someone how to play chess, not by them watching people play chess, but rather teaching them the rules of the game and then teaching them how to win at the game and also how to lose at the game, and then letting the player work through those different combinations themselves. Much quicker, same result every time, and we will always end up with accurate unit tests because they follow that set of rules.
Okay, great, thank you. I'm just very conscious we're nearly up to time. Just a couple more questions I want to fit in though. There's one here just to confirm about Refactor. Does Refactor just add getters is the question, so I think you covered the answer to that is yes, but actually that's quite a significant thing for a lot of the people we work with potentially, right?
Yeah, that's a really difficult thing to know that you need to do that. But yes, today we add getters as part of the refactoring. There's other aspects of testability though that we're always working on. A really interesting question is about the injectability of mocks. If we're not thinking about unit testing when we're writing code, we're not thinking about, oh, I might have to inject the mock, for example, the mock clock into this particular method later on. So we actually need to refactor our code to allow us to inject a mockable object so that we can unit test it. Again, a really typical example that we see. That one's quite a bit harder for humans to execute even once they know what's going on. But again, we do the same. We know where that lack of testability is, which is the hardest part of the equation. And then we're looking at how can we then refactor out of those situations. And there's a whole host of those examples that we're looking at.
Cool, thank you. So again, key point there, I guess, is just that is more on the report side of we can identify where the gap is, and Refactor's helping us to solve for part of that today in a pretty clever way. We're rewriting a bit of your code to make that more testable, albeit in a specific area. So just one or two more I want to get through here. I think this is an interesting one, just from the optimized point of view. And again, I don't know if this is a brief explanation or if it's a bit more complex, but how do we know and how can we be confident in cover which tests should be excluded from a unit test execution run?
So what we do is to validate the confidence level after we've calculated what test to run, is we run a mathematical dependency analysis across all of the code. And so we're knowing that where we say a unit test doesn't need to run, we know that there is no way that that unit test could be a unit test that needs to be run for a particular code change. And we're literally drawing that dependency graph and doing that check. Further to that, we've done a huge amount of testing where we run optimize and we run without optimize, and we ask and we actually measure whenever we catch a regression with optimize, we want to know that it was caught without optimize and vice versa. And we've never had a situation where cover optimize has missed a regression that running all the unit tests has caught. So really, it's mathematically locked in by the fact that we can traverse that dependency tree and see that the test and the code change never actually come together at any point, and therefore can be excluded.
Excuse me. All right, great. Thanks very much, Matt. we're just slightly over time in what we're aiming for now. So let's wrap it up there. Thank you again to everybody for joining us on today's session. Do look out for future Diffblue webinars. If you'd like to try Diffblue Cover, you can do that for free via the free trial on our website. So we encourage you to do that. As I've mentioned, this is a recorded session. We'll be sharing the recording very soon, so watch out for that if you want to get hold of it. And once again, thank you to Matt for your explanation, and thank you to everybody who's joined us. We hope to see you again soon on another Diffblue webinar. So thank you and goodbye.